Thanks, Ron. And Omar, I don't know how far you got into the introduction, but hopefully not too far. But if you didn't get there, my name is Carl Camp. I'm a solutions architect at AWS with the financial services and credit unions team. I'm also joined, as mentioned, by Omar, who's a fellow solutions architect on the team. So, in this presentation, we're excited to be sharing with you AWS's best practice guidance on operational resilience for financial services institution in AWS. Further, at the end, Omar is going to be sharing with you a starter kit that both and I worked on, which is catered towards best practice guidance towards achieving business continuity with AWS for your core banking applications. So we're excited to be sharing that with you, discussing that a little further. If you have any questions during the presentation, we will leave some time at the end for Q&A, but again, Omar and I will be here, so if you want to put those in the chat, we should be able to address those also. So with that, let's get started. Now, in the previous presentation, right, we talked a little bit about resilience, right? And it was overall kind of this is a security posture, but I want to really dive into a little more into what do we actually mean by operational resilience in the context of financial services. So in short, operational resilience is the ability of the financial sector as a whole to prevent, adapt, respond to, recover, and learn from operational disruptions. And this is important as continuity of service, especially for critical economic functions, as this is a key prerequisite for financial stability. And this becomes critically important, especially as we think about compliance. And so when you have a regulator, right, a regulator's primary goal is to protect the financial system and to protect the customers of that financial system. And this has to be the primary focus. As in recent years, as mentioned in the previous presentation, there has been an increase, right, of service outages of financial institutions due to the increased area of attack, right? And there's been a shift in regulatory focus from just prudential conduct policy settings to ensuring more business continuity in case of stress on the financial system. So further, this has led to a focus on third-party oversight and enterprise operational resilience. And so central banks and supervisory bodies are moving to address systemic risks to the financial system through this regulatory lens. And so AWS recognizes that financial institutions, which especially use AWS services, need to comply with sector-specific regulatory obligations, and we're here to assist you and try to meet those requirements. Now, many regulatories around the world are increasing their focus on operational resilience as a result of those growing number of incidents. One of those, for example, just to bring one to the forefront, at the international level, we have the Basel Committee of Banking Supervision, or the BCBS, which issued its principles for operational resilience in March of 2021. And so the BCBS principles, as an example, expects banks to identify their critical operations, which should be consistent when relevant with their recovery and resolution plans, to define their tolerance for disruption of these operations in line with their risk appetite and to test against them. Now, you can see, right, the 7 distinct categories that the BCBS focuses on in regards to financial institutions. And if you want to look this up, right, you can research a little more into the BCBS specifically and see exactly how they're defining each category. But the main point here, right, that I'm trying to get at is this: with all this focus and with all this review of operational resilience, what we want to work on is to try to figure out how do we actually translate operational resilience into a financial institution itself in a way that actually makes sense and we can actually define in data that we're actually meeting our needs. So again, to put it simply, right, our goal is to prevent harm to customers and do not impact the stability of the financial system. And with this in mind, we can begin coming up with our operational resilience plan through assuming plausible scenarios and defining impact of our tolerance limit. So as you can see in this graph, right? Often our plans will include, in general, our service level agreements. With our continuity plan, right, being really the last line of defense for our impact tolerance. So anything beyond that would be considered customer harm and even worse, financially unstable. So we want to consider the continuity plan, right, as anything beyond that we do not want to happen. So what's the data point for our continuity plan? Now there are a number of things, right? When we consider planning for resilience, we need to consider what are the plausible scenarios. So, and there are a number of factors, right, that can cause instability in financial markets. Some of those you're probably aware of can include delays in receiving timely, fast account updates for a systemically important bank. You could have external or internal factors such as a fire or a flood that leads to a lack of service or failure of a data center. You could also have trading functions not operating or meeting stress. Another thing that you want to take a look at is, for example, any outside incidents, right? For example, perhaps malicious intent to try to take down your services. And those can be distributed denial of service, right? A DDoS attack, a cyber attack resulting in use of a cyber vault to recover data and systems, a major impact due to a change or rollback of an application, or a potential network service failure or infrastructure failure, such as not being able to recover a data center. So, with all of this to consider, where does an organization start with their application? Specifically, in our mind, right, your core banking applications. The first place you always want to start, right, especially when you're considering your business continuity plan, is your recovery point and your recovery time objectives for your application. And so when you're creating your disaster recovery or continuity plan for your organization, you most commonly plan for, right, the RPO or the recovery point objective, which is the maximum acceptable amount of time since the last data recovery point, and then also your recovery time objectives, which is how quickly you must recover from a disaster. And so in other words, right, what is the maximum acceptable delay between the interruption of service and the restoration of the service? And this will determine what is considered an acceptable time window when the service is unavailable. And so this is where AWS is here to jump in to assist you in designing resilient, reliable workloads. And so with AWS, we can assist you in guiding you to automatically recover from failure, which, yes, will involve identifying your key performance indicators, such as your RTOs and RPOs, and then working with you to understand how can we automatically recover from failure in terms of DNS recovery, in terms of your compute recovery, database recovery, load balancers, what have you, supporting your core banking application. We can also assist you in testing those recovery procedures. That's something that isn't always easy to do in an on-premise environment, but with the cloud, because you pay as you go and you can spin up resources up and down as you need, you can spin up an environment that's a test environment, and you can test against that environment plausible scenarios to make sure you understand how your workload and core banking applications perform under stress. We can help you understand where you can break up your applications into smaller chunks so that they can scale horizontally to increase and distribute requests across multiple smaller resources so that you don't share a common point of failure. We can also, again, with the cloud, assist you to stop guessing capacity so that you can then monitor the demand and workload utilization so you can spin up and down your resources as necessary without over or under provisioning. And finally, one thing will also help in guiding you is managing change management with automation. And so when considering that, right, we want to make sure that when we're controlling our environment, I mean, really, whether it be on premise or AWS, but focusing on AWS, we can help you with assisting you choosing the right tools in order to control, hey, you can't launch resources unless they meet a certain standard, or if a resource changes, right? Let's say somebody changes the encryption on a resource or something like that, we can then revert back to the state when it was safe. And that's all possible and very manageably in the cloud. So from here, again, we also provide best practice guidance. And I want to turn this over to Omar, who's going to be diving a little bit deeper into some of the strategies that we see our financial service institutions use to decide their DR strategy, also the technologies that AWS provides, and finally the starter kit that we want to share with you. So with that, I will pass that over to Omar. So Omar, feel free to take it away.
Thank you, Carl. So yeah, let's go ahead and get started with the disaster recovery strategies that we have on AWS, right? So when you approach disaster recovery within AWS, there's going to be multiple strategies, and those depend on the RPO, RTO requirements. I know Carl talked about those, right? The recovery point objective and the recovery time objective. And as you can see, starting from the left-hand side, you have the RPO, RTO, and that's in hours, right? And as you go from left to right, it's a scale. And if you look at the costs also increase. So we need to find a balance of what are the SLAs for our workloads or applications, how much downtime can they have, and then choose a strategy based on those, right? Because at the end of the day, we're using cloud to, yes, increase our resilience, elasticity, but also another benefit is cost. So you want to mix these strategies depending on the SLAs that we define, right? So with backup and restore, you can leverage existing backup infrastructure, right? A lot of our customers are using different backup strategies and third parties like Veeam, Cohesity, Rubrik, just to name a few, right? So if you're already using some sort of backup third-party vendor, you can still leverage them today. Instead of backing up to a server on-premise, you can just point that to AWS. And if a disaster does happen, you could restore those into virtual machines. But as we can see here, that takes hours. So for those less critical workloads, that's a very good strategies that we recommend all our customers use. Then you have Pilot as the next one. As you can see, the RPO, RTO is tens of minutes. So with this, you're looking at meeting lower RTO, RPO requirements, right? The biggest difference here is you have infrastructure at the target site, right? With backup and restores, you're just storing your backups in S3, right? And just object storage. And with Pilot, we actually have infrastructure that's sitting in our target site. So if a disaster does happen on premise, we just click a button and we're able to convert that infrastructure into an infrastructure that could handle production workload for our applications and workloads, right? And then you see warm standby and hot standby next to it. So warm standby is similar to Pilot. The biggest difference here is it's going to be a scaled down version of what you have on premise. So you can handle production traffic, right? In this case, let's say you route 10 to 20% of your traffic to the warm standby site in AWS, so it can handle that traffic. And if a disaster does happen, you would just have to wait. The RPRTO reflect the amount of time it takes to scale up to meet that production demand, assuming our environment on premise fails. And then finally, we have the active passive approach, right? So this is where you have real-time RPO, RTO. So you're serving production traffic equally across your production site and also your DR site as well. So if a disaster does happen, the customer won't even notice that anything went down for them, right? You would just reroute that traffic from your on-premise environment to AWS. So now let's talk about our Pilot solution that we have. This is a managed service that we have at AWS. So we have Elastic Disaster Recovery, and some of the benefits of the service, right, is the faster RTO, RPO, right? You have the RTO of sub-minutes and RPO of sub-seconds. It's easy to test, right? I know a lot of times today with the old legacy approach, it's very hard to test without impacting your production workloads, right? With Elastic Disaster Recovery, it's literally just a click of a button and you're able to actually test and validate that you can meet those SLAs that you defined. Lower cost, right? You're not paying for resources that you're not actually using, right? A lot of our customers, they used to have issues with paying for duplicate licensing and hardware for resources that they don't even know they're going to need, right, in the future. Also, you have ransomware recovery, right? You could do point-in-time recovery. And yeah, let's go ahead and cover the next slide, Carl. So this is a high-level overview of what the Alaska disaster recovery looks like. So as you can see on the left-hand side, this is going to be our data center, or it could be another cloud provider, right? It could be Azure, GCP, it could be your on-premise environment. So on the left-hand side, as you could see on those source servers, in this case, let's assume it's your on-premise environment, you would install those AWS replication agents on those source servers. And once you do that, what you end up doing is it's going to then start facilitating block level replication that's both compressed and encrypted into a staging area subnet, right? So this staging area subnet within your AWS environment is going to have small virtual machines running that's facilitating the replications and storing those into EBS volumes. And that's where the cost benefit comes with Alaska Disaster Recovery is you're only paying for the resources that are running within that staging area subnet, which is very minimal compute in those EBS volumes. So you're probably wondering, okay, what's next, right? What happens if a disaster happens? So with Alaska Disaster Recovery, once you configure the initial settings of how you want your resources to convert from that EBS volume into the instance type that you want to select, right? If a disaster does happen on premise, with just a click of a button, Alaska Disaster Recovery is going to convert the data stored in those EBS volumes into recovery instances that are running within a recovery subnet. So then from here, you're able to reroute your traffic from your data center where a disaster is occurring into AWS where you have these workloads and applications running natively within AWS. So as you can see here, it's we support a wide area of different operating system, right? Any database, any application. Same with the source infrastructure, right? It could be physical data centers. It could be VMware, Microsoft Azure, Oracle Cloud. It's agnostic in that way, right? It's the same exact approach to install these replication agents across all these source infrastructures, database, and application. And it's what makes it easy to use as well. So now I want to talk about this guidance that me and Carl created for our credit unions and banks that we work with last year, right? So this guidance helps credit unions back up their application and database layer of their core banking platform for disaster recovery, right? And one thing me and Carl ensured is that this guidance is going to help you not only prepare for disaster recovery, but also make sure that you stay compliant with requirements like GDPR, GLBA, and also FFIEC, PCI, and a few others, right? These are different things that we kept in mind when we designed the solution. So as you can see on number one, the first thing we want to do is facilitate some sort of connection between our corporate data center and AWS. So in this example here, we're using Direct Connect to establish that dedicated connection, right? Another option is you could also set up the site-to-site VPN if you do have that bandwidth and you want to send it over the public internet, right? It won't be as efficient as a direct connect, but that's also an option as well. And then we move on to number two. So here, as you can see, our core banking system is broken down into an application layer and a core database layer. So number two is showing that we're replicating the database over to Amazon RDS, which is our managed relational database service, which helps you operate, scale, and manage databases, relational databases within AWS. It's one of our managed services, and we facilitate the replication for the database using the AWS database migration service. So that's going to go in and do continuous replication into our database that's hosted within RDS. And then we have the application layer, right? Using the application layer, we're going to replicate that using AWS DRS, right? The same solution I talked about in our last slide. So in this case, we have that staging area, which is going to facilitate the replication from our application layer to those EBS volumes sitting within AWS. And let's say a disaster happens, right? With just a click of a button, you're able to convert those EBS volumes within a few minutes to a EC2 instance, right, into a virtual machine that's running your application natively within AWS and ready to serve production traffic. From there, we move on to number 7, right? This is where we have the different observability tools that we have, right? This is going to let you collect, correlate, aggregate, and also analyze logs within your network, your infrastructure, and also applications both in the cloud and your on-premise environment, so you can get better insights into what's happening within your system. And on step 8 over there, we have our different security tools, right? These are the different tools and services that we're going to use to make sure we implement the principle of least privilege, right? We want to make sure we're rotating, managing our keys, whether they're API keys or cryptographic keys within AWS. And then step 9, we have Rule 53, which is our managed DNS service. So using Rule 53, what we're able to do is actually create failover records and also perform health checks, right? So we could actually perform health checks on our core banking system. And if Rule 53 determines that our application is down, we're actually able to automate the process of spinning up those servers and also rerouting the routes and pushing them and routing traffic to AWS instead of our on-premise environment. So I know there's a lot going on here. So if anyone has any questions, feel free to drop in the chat or come off mute and ask away.